Hi, today we're going to do a lesson on the law of sines. Our essential question is, how can I use the law of sines to solve problems with non-right triangles? Lately we've been working a lot with right triangles. We've done the Pythagorean theorem, the trig functions, sine, cosine, tangent, inverse trig, and application problems, all dealing with right triangles. So today we're going to take a look at, well, what about those non-right triangles? The triangles that maybe all three angles are acute, or we have two acute angles and one obtuse. So they actually have a special name. They're called oblique triangles. So oblique triangles are just non-right triangles. And I've sketched out one here on our notes today and labeled each of the vertices A, B, and C. The side lengths are also labeled with respect to the angles, and so if you look at the side that's directly across from angle A, that side is named A. The side across from angle B is named lowercase b, and the side across from angle C is labeled lowercase c. Okay, so in order to kind of discover and take a look at what the law of sines really is, we're going to use what we already knew about right triangles to help us get there. So I've taken and drawn a perpendicular line from the vertex at C straight down to the line segment AB at the base of the triangle. And so that kind of cut our triangle into two different triangles. Both of them have a right angle now, which make it so that we can actually use some of our previous knowledge to build from. Okay, so step number one, we are going to look at the sine of angle A. And so if you look at angle A here, sine, remember, is opposite over hypotenuse. So the side opposite of angle A is x, and the hypotenuse is b. Just looking at this triangle right over here. So we set up our trig formula, and then we can solve for x. Here we multiply both sides of the equation by b in order to isolate our variable x. And that gives us x equals b times sine A. So that's stuff you guys are really familiar with. Good stuff. Alright, moving on to part 2 of what we're working through here. So next we're going to look at figuring out, well, kind of the same situation, but on the other end of the triangle. So look at sine of angle B. Again, it's going to be opposite over hypotenuse. So we have the opposite side is x, and the hypotenuse is a. Alright, and then we solve for x again. X is equal to a times the sine of b. Now what we have here are two separate equations using our trig functions, and they both gave us a value for x. So if x equals b times sine of a and x equals a times sine of b, then our transitive property of equality tells us that those two quantities must equal each other. So here it is written, a times sine of b equals b times sine of a, just by manipulating the equations together by noticing that they are both equal to x. Alright, from there we can just kind of change how it looks a little bit, and then voila, there comes the law of sines. So the way I got from here over to our ratios that are all equal to each other is, well, look, I got rid of a here. The opposite of multiplication is divide by a. So both sides of the equation were divided by a, and then both sides of the equation were divided by b. And that gave us this proportion right here. The sine of angle b over b equals the sine of angle A over A. So you can pause for a second, think about that for a minute, make sure it all makes sense. Alright, and then if those are true for just an arbitrary triangle ABC, then we can use similar reasoning to expand our thinking and say, well, the same thing would be true for the sine of angle C over C, including that ratio also in our equivalent statement. Alright, and those three ratios equal to each other, that's the law of sines. So we have a proportion that we can utilize in solving for missing parts of non-right triangles, oblique triangles. Let's look at an example. Okay, so the notation down here, ASA, that means angle, side, angle, and then AAS, yeah, you guessed it, that means angle, angle, side. Alright, so we're given a triangle where we know a couple of the angles and we know one of the sides. We have to solve for a side length. So on this one, we're going to try to solve for side length B. And check it out, it's across from angle B. And just kind of visually make that connection with what we're seeing in the triangle with the ratio that we figured out over here. Sine of angle B over B, and then look at the triangle. Here's 100 degrees, and it's across from the side B that we want. What else do we notice about this triangle? What information is given? We have a 60-degree angle up here, but we don't know the side across from it, so we won't use the 60 right now. But look at angle A, it's 20 degrees, and that acute angle is directly across from this side that's labeled 4. So now we have enough information. We have 3 things that we know and 1 thing that we don't know. So we can make a proportion and solve it. Alright, so we have sine of angle A, which is 20 degrees, over 4, equals sine of 100 degrees over B. Our proportion is set up, and now we just need to solve for B. So the first step I did was I multiplied across, found those cross products. So B times sine of 20 is written here, is equal to 4 times sine of 100. And the second step in solving the equation was to divide both sides by sine of 20 degrees. And then it's good to punch all of this into the calculator all at once. Because if you do it in 2 steps, then it's going to be rounded twice, and it's less accurate. So let's look at it all together. So we have 4 times the sine of 100 degrees, to close my parentheses there, divided by the sine of 20. Okay, and we got to make sure that our calculator is in degrees because that's how our angles are being measured here. So, yep, looks good, it's on degrees. So we can go ahead and push enter. And we get about 11.518. So that is our missing side length. Alright, let's look at one more example. Okay, so now here's another triangle. Oh, it's very creatively named. It's ABC again. And we are given this information, this list of information. Angle C is 102 degrees, angle B is 29 degrees, and side B is 28 units, whatever kind of units they happen to be. And then see the little dot, dot, dot right here? Well, just by knowing the triangle sum theorem, I was able to figure out, well, angle A, that must be 49 degrees, because we can simply take 180, which all triangles sum up to, and subtract our 2 given angles. So take away 102, and from that, take away 29, and then we see that we're left with 49 degrees. So now we actually know all 3 angles in our triangle. Okay, so that's where that came from. And then I sketched it out. It's important to kind of visually see what it is that we're working with. That way we're creating the correct ratios with the sides corresponding with the correct angles and whatnot. And so make sure that you sketch it out appropriately. Notice how the 28 here is across from angle B. Okay. And the A is across from angle A, which is 49 degrees. So it's all lined up. Okay, next we can set up a proportion, and I'm going to solve for side A first, and then in a separate proportion, solve for side C. So if I'm missing A, then I need to take the sine of angle A on top of that. So sine of 49 degrees over A is equal to sine of 29 degrees over 28. So that came from angle B over side B. And this is angle A over side A. Alright, cross multiply, get our cross products there. So 28 times sine of 49 degrees equals A times sine of 29 degrees. divide both sides in order to cancel out the sine of 29 degrees, leaving us with A is approximately 43.588 units. Okay, same steps for finding C. So pretty much if we're given this limited amount of information, we can find out everything else that we need to know about this triangle, just taking it in steps. Okay, so what is sine of 102? Check out our triangle. Yes, that's the sine of angle C. So here's our ratio. Sine of angle C over C equals the sine of angle B over B. Alright, and we plug in our values. So we have sine of 102 over C equals sine of 29 over 28. Cross products again in order to solve. So here that is below. Divide both sides by 29, by the sine of 29 in order to isolate C. And then remember again, put this all in the calculator at once. Okay, so clear the calculator. We have 28 sine of 102. Close up those parentheses. Divide by the sine of 29 without hitting enter first. Just go ahead and do it all at once. There we go. And then our answer is right there, 56.493, rounded to the nearest thousand. Okay, and you can kind of summarize what we did in today's lesson. But that is the law of sines. There's a little bit more to the law of sines as well, where we look at an ambiguous case in the future where we can solve for a missing angle, and sometimes there's different answers that we can get with that. So we'll look at that a different time. So that's it for this lesson. Alright, thank you.